Hello, good morning. My name is Beth Fawcett, and today I am doing a little bit of a kind of, I guess you could say, a code with me, a plan with me. I am currently working as a data scientist, and this is what my uh, project space looks like. So I use this software called Trello to keep track of kind of everything that's going on in a project, the particular project that I'm working on right now. It's called Tracking Potential Solvent Interactions. And my background is I'm a chemist, and this is some of my own old research data that I am trying to apply a new tool to see if there could be something else going on. So I have on the left hand side of my workspace here, I have project components. I'm trying to learn agile development. So that's kind of what's going on here. This is kind of like my, I forget what they call it, but kind of like a work list. I'm going to start working on the project, so I'm going to go ahead and start my timer. This project is taking oil gas chromatography type data to determine if a concentration threshold can be found at which a solvent begins to react with an analyte to explain strange dissolution phenomena for the purpose of contributing to the growing library of information regarding the difficulty in studying chlorinated bicyclic ethers. Basically, what this means is I want to see on a standard curve, so just picture a graph that has a line on it, to see if there's any fluctuations in that line that tell me there's a different pattern going on. So that's what I'm looking for in this project. I've completed a couple of things so far. I have pulled down some data from the database, and I kind of want to talk about this particular card. I've got a label that says, I've done this. This is a story, meaning this is something that a particular user would want. And in this case, as a scientist, I want to read client provided data so that the scope of next steps in importation and cleaning can be determined. This is really important whenever you're starting a data science project, is to just look at what data is available to figure out how long it's going to take to clean before you can move into machine learning. That's honestly the biggest part of any data science project, is transforming data into a usable state. The word read is a particular coding based reference word, and I'll show you that here in a little bit. And up here you can see size, spent, and remaining. This is what I'm using this card size power up to do story points here in Trello. Everything that I'm showing you in Trello today is something that's free. And you can see that I access the cloud to determine the file type. In this case, it is text files that are tab space delimited. Look at headers and determine delimiters, in this case tab space, to determine data treatment plan. So sometimes whenever you get data, especially from, a scientific instrument, you're going to get a header that has like tons of information. And in this case, it tells us, so this data was collected off of a gas chromatograph. So it tells us like the run time, it tells us the starting and ending temperature. I think the analyte, or not the analyte, the thing that dissolves things, solvent, is even in the header. So those headers can give us a really good idea about the data type and the project that we're working with. And something that still needs to be done is I need to read all of the files from the client, in this case myself, successfully. And then I have create space for data and transformations, I want to create a space. So in this case, it's on my local hard drive. It can also be in the cloud. But you need to create a space where you can change data without impacting the original raw data. Um, so I created some pathing and some different folders that you'll see here in a little bit. As a researcher, I want to communicate data structure so that important and study, so that, oh wow, that's really confusing. So that important and pertinent data is used in this study. This is some details about the study and what's going on. There are 3 trials for each concentration. The concentrations range from 0 to 100, incrementing in 5. There's an additional trial for 25 micrograms per liter. There are 2 columns of data, time and temperature. Time is the independent variable and temperature is the dependent. So, as a researcher, we talk about, or as a scientist, you talk about independent and dependent variables. What that means for me as a data scientist is my target variable is going to be the temperature, the dependent, the thing that changes, that's going to be my target variable, which means everything else should be considered a feature. Okay, and then what we're going to be working on today is pulling all of our client-provided data into our workspace. So I'm going to go ahead and start the timer on this, and we're going to pop over into our workbook. So this is my workbook. This is what a common data science workspace looks like. It's going to be this biggest portion of your screen, this white box type stuff. This is called a Jupyter Notebook. And then there are some other things on the screen as well. I have my task manager up, and I have this program called SpeedFan running in the background, and that's kind of the information that you're seeing on the top right. I thought it would be interesting for viewers and people who are interested in computers and machine learning and how it all works to kind of see what happens to my own computer as we go through and run this process. The biggest change that you're going to be seeing is Wi-Fi, and you can see that I have a pretty decent load right now because I'm streaming. So that is what's going on in the top right. I do have 2 GPUs. I have an onboard GPU that's embedded into my CPU, and I have an NVIDIA 2070. And I know that that's a little bit out of date for all of you computer aficionados out there. However, after doing some research into what newer video cards have to offer, there's one particular thing that newer video cards struggle with, and it is this thing called accelerated linear processing. It's not the exact term, I can't remember that third word. It's processing, it's computing, it's something. But basically what that means is those newer GPUs are going to struggle with machine learning concepts, because in machine learning we use a lot of linear algebra. We do a lot of calculus. We do a lot of calculating an entire space as we move on a curve. And so my older video card is actually out-competing those newer models because they struggle with that linear algebra portion. They're great for gaming, but for machine learning, some of the older cards are still a little bit better. You can see here I have my headers, and those are pulled directly from my Trello stories. So first I want to create space for data and transformations. I know that I want to read in data in this library in Python. I'm coding in Python in this library called Pandas. And so I want to make sure that I have Pandas installed. Actually, we're going to restart this entire kernel. What that means is I've just cleared my workspace, and you should be able to see that in Oh, that's kind of annoying. Hold on a second. These were right earlier today. Let me make sure that the terminals are showing the right thing. There we go. Okay. So I have two terminal windows up, or they're not technically terminals, but they function as a command line. It's this program called Get Bash. Yes, I'm still using Bash because I'm on a Windows device, and I know Zish is out there, but I still prefer Bash. And I know that there's lots of opinions about that out there. Whenever I code on my Mac, I use Zish. Whenever I code on my PC, I use Bash. So the top one, the top black box in the top left up there, you can see that is information about how my project is interacting with the cloud. So that's going to be where I do all of my GitHub commits, and that's like where all of my tracking is going on, right? So you'll see some of that later on today. But that bottom black box that's right above my video right now, that particular Git Bash terminal is talking to us about the status of our workbook here. So I just reset it, and you can see it says replaying 3 messages, restarting or restoring connection. Basically, I just restarted the kernel to kind of clear everything out. So I'm going to run pandas and import it. I know that I have a successful import because I'm getting a version. Then next, this is the space in the background that I have set up for some of our transformations. So I have a folder called data, and then I have this kind of super folder called projects. Then inside that, I have a data folder. So that's where all of my data is going to be stored. It is completely separate from the repository. And that's really, really important. You don't want to store your data in the same place that you're storing your code. And this is a big thing in machine learning and a mistake that I made frequently in the beginning. The thing about data is it's big. And that's basically what it boils down to. Data is big. So right now there's not a whole lot of solutions out there where you can store your data and your code side by side without spending a ton of money. So I'm keeping all of my data, all of my transformations locally for the moment. Whenever I package everything up at the end of the project, I will probably release my transformed data. We'll see. I haven't decided yet. And then I have a project folder called Tracking Potential Solvent Interactions. And so I have the data stored in the data folder, and then the code base actually stored in the project folder. So you can see here I have the data path, I have the raw path. This raw means this is the raw data that I got from the client. Then the interim path, this is like any kind of, I guess, mid-stage transformations that are being done. Then the processed path, that's going to be where I store the data that's passed into the machine learning model. Then the project path, that's where all of my code base is going to be stored. I want to make sure I ran that. Great. So I have my space for data and for transformations created. I have some terms here so that I don't have to type out this entire long line every time. I can just type out raw path or interim path or whatever I need. Next is communicate data structure. Now, this is something that I took directly from that Trello story about the commentary about what's going on. There are 3 trials for each concentration. Sorry, this music is bothering me. So we're going to skip this song. And we're skipping this one. Okay, great. Okay, so next, this is coming directly from that comment from the researcher. So there are 3 trials. So I'm going to label them 0, 1, and 2. And this is just because for coding, it's easier to start with 0, even though our brain wants to start with 1, 2, 3. And that's okay. And then we have our concentration list, which was from 0 to 100, incrementing in 5. So now we have something for our trials, we have something for our concentration. Then for file names, so in the actual file directory, I have the list of names, but I don't want to just copy those word by word into this coding workspace. Instead, I'm going to get a simple algorithm to do that for me. And trial for the 25 micrograms per liter, we had a 4th trial, so I'm just adding that one at the end. So this is our full list of trials that we have available. It's a lot. It's a lot of files. Let me go ahead and run these cells right quick. And then I want to print the length of file names so you can see how many files we have. So we're dealing with 64 different text files. That's a lot. They're not in one file, they're not consolidated. It's just they're all in separate files. And a lot of times this is kind of what happens because, you know, we're running this instrument and then we're saving that file and moving on to the next run. There's not really a whole lot of parsing of information, right? It's just, you know, collecting it as much as we can and as fast as we can because, you know, a lot of times lab space is scheduled. So you want to do your information parsing later. And in this particular case, these particular gas chromatograph runs, they were 7 minutes. So basically that meant I put in my 0 concentration the first trial, and then I waited 7 minutes and then did the next one. During that 7 minutes, I was prepping my samples, making sure everything was in order. I pre-mixed everything and refrigerated it before running all of this, but yeah, 7 minutes is not that long whenever you're in like goggles, gloves, and you're having to swap out gloves in between and make sure that you have the right sample and you have, you know, all of your stuff that you need to flush the column if you need to, and it's just not that long of a time. So you don't have really time to parse data while you're collecting information. So next I want to pull the data into the workspace. So I have this for I and file names. What that means is, you know, for every one or every entry in file names, read the file, and it's in the raw path plus each file plus the ender, and then I converted these into CSV files. And that I stored those in the interim path. And the reason why I did that is because it's very difficult in Python to work with text files. However, once you have a CSV, it's really easy to look at everything. It's just because they store information a little bit differently. So I pulled the data into the workplace at this point. But this is, notice that this is still reading. I'm reading the reading the CSV. I'm converting to CSV. I need to write data. So that basically means I still have some work to do in this particular section. However, before I wanted to do that, I wanted to determine what was in the files. So I looked at my freshly made CSV files, and I wanted to figure out what delimiter was going on. So I looked at a tab space delimiter, and this is my output. This is still very rough. I know that my characters are coded in UTF-8, that's great. I can see when the run was completed in 2012. I can see what software was used. It's Veneer software, which is now considered a legacy type software. And, you know, I looked at a different separator, a different delimiter. I looked at a bar delimiter, which sometimes is used. And that was great too, but I still get this like tag type stuff going on. Um, so I wanted to look kind of at them side by side. Just, you know, later, so this is the first 5 rows of data, right? So I wanted to look at something like further down. So I looked at rows 40 to 45, just kind of like arbitrarily, to see basically when this header kind of stopped. And you can see it's kind of deep in there. I need to run this cell. And I want to run these too. And this one too. Okay, so here I wanted to change my directory into my raw path. Basically, the reason why I did that is because I'm now moving out of working with the... Wait, why do I have that? Okay, hold on. I can actually delete that cell. Then I wanted to look at this with Beautiful Soup to see if it was a little bit easier to look at. And I know based off of how this data looks that it's probably stored in an XML format that was then just, you know, exported into a text file. So I wanted to use Beautiful Soup to look at it. You can see here I'm looking at it with XML. And I wanted to do this with just one of the files to see what was going on. And then I used this function Prettify so that we can actually read kind of what's happening. And there's a lot of stuff. So we have that this is XML. We have the version of XML that is written in. We have the encoding, which is great. We have file coherence. There's one singular file, which is great. We have the version of the software that we were using. We have the date and time that this application was run. We have the copyright information. It was run under Veneer software. And then we have the actual file name that it was stored as originally. And we have the save time, which was pretty cool. And you can see that the person did not put their name in, which to me is kind of funny. The creator OS is 2. I have no idea what that means. The app, I have no idea what that means. Absolute version. Radians, okay, we have 1 radian. Radian is, you know, a unit of measure. Number of derivative points, 7. Number of smoothing points, 7. That's some interesting information that we can use in our potentially a transformation later on. And then we have some other information about the graphs. Show 0 on toolbar, show data mark on toolbar, graph match, whether or not it was stationary. And we don't have access to those graphs, so we have no idea what they look like. Creation date and time, modified date and time. You can see it was modified 30 minutes after it was made. And this is actually a year later from the original run, so I have no idea what that's about. Then we have some bounds, which is pretty cool. And we have some window positions. We have all sorts of really cool information. So I always like to review the headers especially whenever I'm reviewing scientific information, because you can find some really cool stuff in these headers. Now, do I want all of this to be in my data frame? Absolutely not. But I do want to take note of a couple of things, like the smoothing is particularly interesting to me, but I don't need to know that the graph output was an Arial font, right? So there's just tons and tons of information in here about what was displayed that day. And I'm kind of curious too how deep this goes before we start getting to actual data, because the actual data is supposed to be in here too. You can see a lot of information about the column. Okay, here we go, column cells. So we know that the name for one of the pieces of data is column cells. Because this is incrementing up equally, I bet that this is time. And that data was recorded, what is that, milliseconds? So I now know that if I want to find the data, then I need to look for the tag column cells. And this goes down, and as I mentioned earlier, this was kind of like a 7-minute run. You can see it ends there at 7, so that tells me 7 minutes passed by. Then we have some more information. So we now know, because these are separated by columns, all of these tags are column specific, which is kind of interesting to me. And so there might be some additional information in there that we could get about the columns. Now this readout is going to be the temperature, and this is in Celsius. So you can see that this is below room temperature. And scrolling down over the 7 minutes, you can see that there's a depression here where it goes from 19 down to 15. And then we have this crazy spike. And that's kind of what GC is all about, right? So I know as a scientist, I want this graphed, right? I want to look at the graphs. I want to be able to interpret what's going on and find my peaks. And if I can find my peaks, then I can get some information about composition, right? So the whole point of this particular project at the time was to develop a standards curve. So I want to see at what point and how the peak shifts based on concentration level. Going back as a data scientist, I want to see this graphed, but I also want to, develop features. And the scale, seeing the scale, that most of it is, in the 10th place, and then we get up to the thousands as well. That kind of gives me an idea about potential transformations moving forward. And then I have the ending of my column information. Then I do believe, okay, that's interesting. We have a port reference, so this was exported somehow. I do believe most of this is ending tags. Oh, here we have some of the experimental parameters, which was pretty cool. So this is stuff that was set up, kind of how the GC operated and worked, which is cool for publishing scientifically, but some might be necessary as a data scientist. That still remains to be determined, but I know that there's some information here at the very end of the document as well. We have the calibration maximum. We know that the calibration was set up to 800, but we know that we went up to around 1500, so that could be interesting as far as the particular data was set. And I know at the time I was trying to attach my GPS information to this data. So I think that's what this Google Maps stuff is. I'm not sure if I don't believe it was actually successful. Then we want to find all of the column cells. And basically this first one gets us all of our timestamps, right? And then this next one will get us all of our temperature, which is great. And then for times, I want to find all column cells, and this is something that I found out about after. I want to split them by space or break. That's kind of what here, there's like, when you highlight in docs or documents, Word type processor, and you highlight and you do, like, there's this space at the end. That's an invisible programming denotation for this thing called break, and basically it means you hit the enter button. So there's a break here, and so I want to split by the break so that I get individual discrete times. And then I transform this command float. Where did the music go? Oh, I got to the end of the page. Let's go to the next page and let's play it. Cool. Okay. And let me pull back up my channel. Okay, so this idea of float basically says, you know, these are integers that have decimal points. And so I wanted to make sure that that was included. And we know that these are times, so I want to put them in this times list. And I want to make sure that they're float. And I only wanted to append data that was of the float type. And if it was not of the float type, then I didn't want it. Basically, I ended up with some empty spaces. And so I want to look at the very end of this data set to make sure it ends at 7. Make sure that I have all of my gaps. Then I want to do the same thing for the temperatures. And then I want to make sure that they're the same length. So basically what this little section of coding here from this beautiful soup part on, I now know that I can get my data of interest out of one singular file. Remember, there are 64 files. So I've gotten this data out for one singular file. And I called it times and temps, which is not great. So this is where the actual part of what I wanted to do with you guys today starts. Was how do I take this idea in these two cells? How do I take this from one file and apply it to every file, all 64 that we have available? So I know I need to do this part here. I need to open each file in XML. Then I need to find column cells 0 and 1. And then for 0, I need to run this algorithm. But how do I do that in a way where I can keep track of the concentration and the trial number? So this is where the work begins. I've thought about this a little bit. I've done this type of thing before, but you might see me get a little bit frustrated. And so now that we've completed this task here, I believe, which was, determine what data is available in the file. And I want to make a comprehensive list of what data is available. So I know I have the times and the temperatures that the scientists mentioned, but I also have every tag here. And we've made some notes so far about what's important. I should probably make up a separate kind of, let's actually do that too. Because I said I was starting on pull data into workspace. I want to write data into a local workspace so that cloud costs are, so let's focus on this part later, but I'm going to put in a space for it. And I'm going to do a level 4 header. List of available data in header footer. And then I want to start making a list there. I know that so far I know that I have the data type, which is XML 1.0. I also have the encoding, which is UTF-8. Those are things that are generally helpful. I know that I have application build time. Oh, so this is when application build time. This is when this software was updated. So I know that it was a mini GC from Veneer Software and Technology, and its version was 3.8.6. So this is, I guess, data collected by. So I would be able to go look up information that I needed to about that. So that's just from looking here. I'll go back in and add some other stuff later. So I need to find a way. So we've already mentioned we wanted to do this with open portions. So basically I do one thing at a time, and then I go back and I kind of pull out the components that were necessary. So with this soup that we made, we pulled out column cells 0, and then we pulled out column cells 1, and it looks like actually we did this find all command kind of embedded. So let's start here. By the way, feel free to make a comment if you have a question. This stream is meant to be kind of like a work with me and ask me anything type thing. So if you happen to be watching later, after I post the stream as a video on my channel, feel free to pop a question into the comments section, and I would be happy to address it in either a future stream, a future video, or if I can, comment in the comment section about what I'm working on. And then I want to do the same thing for temps. Instead of this find column cell. And then my kind of check was to make sure that the length of both of them is the same. If it's not the same, then I know that there are problems. Okay, so this is for one singular file. And this is starting from soup, and then we have that soup here and here. So we want to make sure that anything that references the soup is embedded underneath the soup variable. We want to start an empty list 4 times and append as necessary times. And we want to restart that for each new file that we generate, right? So this is kind of what the inside of the loop that goes through all 64 files will probably look like. This is the inside of the loop. And so I want to run this, and let's actually make sure that this prints out. Okay, so we know that this still works, this still functions. We get to the very end of this particular structure. So basically what I did is I went through up here where I was going through things, you know, one at a time, one by one. I took my soup here. The reason why I decided to go with beautiful soup was because I realized that, you know, separating by bar delimiters, separating by tab delimiters, working in pandas wasn't actually going to work very well for me. So I kind of deviated off, I wouldn't be able to reference specifically what I wanted because the tags are still here together. So all of the data actually ends up on one line that starts with the columns, this column cells tag, and so that would all be in one line whenever I was working with pandas. Whereas a beautiful soup, I could get it into separate lines, and so that's why I went with beautiful soup. Now, one thing that I'm curious about that I don't have here is if I take times and I look at the very first entry, it's actually 0, 0, which is great. So whenever I did the find all column cells, even though when you do that here, it prints off the column cells at the very beginning, and at the very end, I think it closes it, you don't actually get those tags in your list. They're just printed out so that you know that the tag is there, because it's part of the type of data that you're looking at. So that's pretty cool. I don't need the cell anymore. Okay, so I know that this is going to be the inside of my loop. This is not part of the treatment plan. This is part of the this is part of the writing data. Okay, cool. Let me see. I think I can actually go ahead and move this cell up to the appropriate section without losing what I have here, determine what data is available in files. I think the only thing that I need to do as well is move up my beautiful soup import. So whenever I'm working in a Jupyter notebook like this at the very beginning, unless I know for certain that like pandas is at the very beginning, OS is at the very beginning, I tend to pull out my imports into a single cell so that I can move them around because I don't work in order. I don't think anybody works in order. And I think that that's what's great about Jupyter Notebooks is, you can end with a really cohesive document, but you can also drag and drop code cells, which I think is great. So I'm going to restart this kernel to see, to make sure that everything still runs without any errors. This is the part that I'm looking for here. I want this to run. So this did not run. Why did this not run? There's no such file. Okay, cool. I hadn't made the file yet. So that's something that we need to look at here. So where did that text file come from? Or rather, are we not in the right directory? Yeah, we're not in the right directory. Okay, cool. So I just copied this portion here. I didn't actually change the directory. So that's something that can come from, working with your data and your code base separately. Is, whenever I'm up here, I'm starting in my code base file. That's what I ended on, I believe. Yeah, I have the data path and then I have the project path. But I started this notebook out of the code base directory. So I need to change into the data directory, I believe. And that should run. Yep. Okay, so it's just in the wrong directory, which is cool. So this still operates how it should, which is great. And then I'm going to just finish out the rest of my Explorer here. Okay, cool. So I have the interior of my pulling data into workspace loop completed. At this point, I'm actually going to go ahead and make a commit because that's even though it's a small milestone, like I have added something substantial to the code, and I want to have a place to come back to if there's any errors in testing in the future. So I want to make sure that I know that this interior loop works. So whenever I start working on developing the exterior loop, if something starts breaking down, I know which portions are not a problem. So in the top terminal, you can see that I have my cursor blinking up there now. I'm going to get the status of my notebook, and you can see in red there that I have modified my notebook. So I'm going to add the notebook to the commit that I want to add it to. This warning is just, it's not a bad thing. It's basically just saying I can suppress it, honestly, if I wanted to. But it's saying that, GitHub is working with a more updated versioning system than I have on Git right now, and that's okay. That's actually preferable. So I want to get status again to make sure that I have uploaded everything that I want to upload, and you can see it went from red to green, so that kind of means I'm good to go. So I'm going to go ahead and make my commit, and I want to put a message that includes what I'm doing. And good commit messages start with a verb, and then it's maybe 50 or so characters that describe what happened. So I developed the interior loop for writing client data to interim. Client data to, I'm actually going to put DF for data frame. And yeah, that tells me that I got a portion of the way to developing the data frame that I will feed into our machine learning model later. And I can see there I have one file changed. I have 80 insertions and 38 deletions. That is lines of code. So here you can see that I have this ln6, but I have 3 lines of code there. This ln9, I actually have 18 lines of code. So that's kind of what that's referencing. That's why it's so many. I've changed 80 lines and I deleted 38 lines. Okay, so here, pulling data into Workspace, we have our interior loop ready, kinda. Now, I need to make a couple of decisions, and I want to kind of demonstrate what these will look like. So at the very end of all of this, I want to have a data frame that is informational, cohesive, and relates all of the data appropriately. Since I got all of this data in singular files, I get to make the decision as a data scientist how to align those files for appropriate, usage later on. So I know that there are basically 3 trials for each concentration, right? So I could put these, side by side, like this, or I could end up with something that looks a little bit more like this in my rows, right? So, and then I could just have 3 rows, right? And it's hard to decide, which one is better. I already know that I'm going to need to use like a multi-array type setup because I want to be able to do some statistical analysis on all of the trials that were 0 concentration, all of the trials that were, I think it's 5. I should make this more accurate. 5 and then 10. Hello. I do not want my inspect page, thank you. I had 10. And then I had 15. So I need to figure out which way I want to set these up. What's more important? Do I want to take these and do an average across all three? Or do I want to calculate based on those? Do I want to include all of the data in this more tensor type fashion? And I have to remember too that for I have 25, or I have 4 instead of 3. And it's the only one like that. So what do I do with this extraneous 25? Do I average it? And leave everything else an average? Because these would all be averages, right? Now, I know whenever I initially studied this data, I went to this average route. To try to figure out the shape, the pattern of my standard curve to see if it was linear or if it was exponential, kind of what was going on with it. And I have to remember that embedded in each of these trials is, those 2 columns of time and temperature. So I have to figure out kind of how I want to evaluate that temperature and what I want to do with this 25 data. I think what I actually want to do before I kind of figure out how I want to pull all of the data in and move forward with this master loop here, I think I want to look at what I should do with this column or this trial, this 4th trial for 25. So that's actually going to be under this other category here, create treatment plan for present data. So what I want to do is I want to take this loop and apply it to my text plan. And I know that I'm going to have to develop a lot of different treatment plans. So I'm going to call this one management of 4th trial for 25 micrograms per liter of triclosan to isopropanol. Okay, so I want to change this to 25 and I want to do times, I want this to be 25 0, and I want this to be temps 25 0. Hold on. I just noticed music disappeared again. Let's go to the next page. Let's play this page. Okay. So I know that the times are going to be the same for all of them because all of the trials started at 0 minutes and ended at 7 minutes, and they incremented up in 5 millisecond intervals. So I want to record the times once. However, I want to record the temperatures for all of the files. So I think I can create a for I and range 0 to, and I know that this one goes up to 3. I think I can do this. And this needs to not be an I. Let's make it a J. And I know I have it up here. This. Yeah. Actually gonna take that with as an example for what I'm trying to do here. With 25 dot plus string J plus I need a 0, a 1, a 2, and a 3. I'm gonna have to do this a little bit differently. Originally, I just wanted to append the list, but you can't add a variable. Like, you can't have this as a variable within a variable name. Your variable names have to be discrete. You can't you can iterate through them, but not whenever they're on the left-hand side. So I'm actually going to make a data frame 25 is equal to pd dot data frame, and then I'm just going to do df 25 time. No, I want that capitalized so my graphs look pretty later. Equals times. That way I can do trial. And then I can rename them later, I think. Then I want to see df 25. Okay, let's see if this works. I need my soup. Okay. Okay, so I got time in there. Hold on. df trial equals, I need to change this, flip I. There we go. I got one trial and it replaced it each time. I think I can do, here I can do a plus, I think brackets J. I forget how to do this part. Trial underscore plus J. str. There we go. There we go. Okay, so we have the different trials and we can see that the numbers are different. Let's do a sample and let's look at 10 rows. Okay, this gives us a interesting view. We have our time. Let's, instead of doing sample, let's look at rows. 300 to 325. It's a minute. Okay. What about 500 to 525? 2 minutes. I'm trying to remember where the spike was. It was kind of close to the end. So let's try 10,000. My problem is that trial 1 and trial 3 and trial 0 are the exact same number. So I don't know if my function worked. So I'm trying to find a place to look where the numbers might be different. Okay. That's at the end. Let's see where that spike happened. It's kind of close to the beginning. Okay. Let me do this. DF25. I want to look at trial 0. Yeah. Dot unique. Yeah, it's the same number the whole time. So why would that happen? Okay. Let's do temps equals list. Temps dot append I. Equals temps. So what I just looked at was here, I looked at the new unique values for trial 0, and they're all the exact same number. So that means I have something a little wonky going on. So what I added was this list, and this list will start over every time we restart the for loop. I have an empty list, and for I n, if that I is a float, I want it appended to this temps list. And then on that same level where we're restarting that temps list, I want the trial plus whatever j we're on, so this will change whenever we start the loop again to equal that list that we've created. So I want to see if our numbers change there. Unexpected indent. So I need to move this outside of our try except loop. That's what that tells me. And I want this to go there. Yep. Okay, so I have a number change here, so that's good. That's really good. And here I should have, yeah, a ton of values. That's much, much better. Okay. And let's do 175 to 200. Yeah, here we go. We got some spiking happening here. But not for trial 2. So let's see what's going on a little bit later. The trial 2 is still all the same. So let's look at DF 25. Trial 2 dot unique. Okay, there's only 3 unique values there, or 4 unique values there. So I think that that's why I ended up doing a third trial. So there are 4 trials, but this third one should be discarded. Here, let's do this. Let's print the length of trial underscore plus string j dot unique. Let's print the length. The phrase. Okay, I need another parenthesis. Okay, so we know that the lengths are definitely very different. We want significantly more. So instead of trying to include this trial 2, I think we have justification necessary to exclude trial 2. So what I would want to do here is to write that up. Since the number of, let's prove that it's statistically different, because that's kind of what I'm getting at. But I haven't proved that they're statistically different yet. Since the length of trial 2 is much, the length of unique variables in trial 2 is much shorter than for the other 3 trials. Trial 2 should be excluded. And I also suspect that there's no spike in trial 2 either. Let's get that up and going. I'm trying to think. Import matplotlib as plot as, it's been a while since I've coded, guys, forgive me. SPLT. Can I do that? I can. So let's do that. Let's do PLT. Can I do plot? Oh, it has been a long time. This is me pulling up Matplotlib on my other screen so I can figure out how to make a scatter plot, because I haven't done it in a very long time. That's what I thought. Okay. So I want x to equal df25. My x is going to be my independent variable. So in this case, that's times. And then my y is going to be df25. I'm talking about trial 2. And then I want plot dot scatter at xy. And I want plt dot show this. Aw, boo. Times. What did I call it? Oh, time. Cool. Yeah, so that's great. Let's do this a little bit different. I think I can do my X min and max. I think I'd have to do that with a figure, and I am not prepared to do that today. Let's look at this graph compared to trial 0. That's what I would expect from a GC. A GC graph is something like that. This looks like categorical data. Yeah, so much better. Trial 3. Okay. And then I'm gonna put, additionally, the shape of the data is much different on second glance. The temperatures recorded are no different than room temperature. Suspect that the analyte was not injected. That sounds like a user error. So trial 2 should be excluded. So whenever we're talking about up here, you know, the shape of our data and how to include this trial, this extra trial 25, we now know that trial 25.2, is it 25.2? Yeah. Should be excluded. And I kind of want to go into my directory and just delete that file and rename the .3 to .2 to make all of the rest of this easier, but that is modifying data, so maybe not. Hold on. I actually want this to be a thing. Break. Then I think I can add these break denotations to keep my planning structure here in my markdown cell. Yeah. Okay. want to remember what this is. Example structure for how to incorporate files into incorporate singular files into how about multiple files and trials into a singular data frame. And this is what we were looking at before, excluding trial 25.2. And then I want to break here. We want to break there. And then afterwards, it would be this same structure here, just with one less 25. And then here, our other option is to not have that and not have these averages. I'm kind of inclined to set it up both ways to figure out which one has an advantage or a disadvantage down the line. I kind of want to set it up this way for some of the statistics that I want to do, and I kind of want to set it up this way for actual machine learning. First, I want to do the statistics portion to figure out if any of the trials are statistically different from each other. Kind of like here, how we kind of excluded one of the trials because the shape of the curve was different and the unique values were different. And that all came from, like, you can see here, like, these numbers are changing and this one isn't. So something was wonky with that one. So I kind of want to go through and use this second structure for some of the statistical analysis to figure out if averaging is the best method of incorporating all of the data into one data frame, or if they are statistically different from each other. That poses an interesting point, and maybe we should keep them separate and keep them set up like this. And in that case, we would be using a multi-array. I've used multi-arrays before. They're very difficult to implement effectively. We could also set it up as tensor type data, which would be interesting, but that would require incorporating TensorFlow for our machine learning and kind of restricts what we can do later down the line. So I don't necessarily want to go that direction first. I want to see what we can do as far as some statistics and see what the best method of representing our data is going to be. For today, what we've accomplished so far is we figured out our inner loop, and we also figured out, this fourth trial compared to the other three. We figured out that we need to exclude one, which kind of gets us better set up to start developing this outer loop here. And in fact, I'm going to put a note here that this represents the inner loop of our big, open, everything all at once algorithm. Still need to develop the outer loop that iterates through all of the files. I knew that because this is just tagged on at the end, this 25.3 and our file names list, we need to actually go in. What we can do is for file names, we can drop this 25.2 run from our file names list. And that's probably how we're going to read everything in. But I'm going to save this for now. I'm going to, let's see here. I want to, do I have all of my markdowns run? No, I do not. I want that run. And then before I quit for the day, I just want to make sure that all of my cells run without any errors. I know that I changed the order of some things, so I just want to make sure everything still runs, so that way when I come back, everything is clean and ready to go for next time. Okay, not all of our plots have populated. We need to clean these up and add some figures and add some titles and, you know, cut our X and Y, or our axes. We need to do some work there. So maybe we'll talk a little bit about graph representation next time. But until then, we have some rough stuff. And let me pull up my command line to save everything that we've done so far. Git status, and we can do git add our changes. And my next screen is over to the left. That's why I'm looking over there. I want to git status to make sure everything was added. Then I'm going to commit. And I would say that the biggest thing that we did here was you know, the management of this fourth trial. So we determined treatment of trial of the additional trial for the concentration of 25. Git status, and I want to make sure that I push everything up into the cloud. So I'm going to go ahead and push. You can see everything went successfully. If it didn't, there would be lots of red text. So I'm going to go ahead and end the stream here for today. I guess I'm going to go back into my Trello here and stop my timer. And I just realized just now that I did not start my project description timer, which is kind of like my timer for the whole project. So I'm going to set a timer and just let that run while I'm not working so that I can get up to the 1 hour and 21 minutes. So this size here of 4, that determines like the difficulty of the task. These are my story points. So to be able to write all of the data into my workspace, first I had to figure out what to do with that anomalous or a different set of data, so that was a little bit complicated. And then I'm having to write an algorithm that'll iterate over everything. And so that's why this has 4 story points, whereas a lot of the other things have 2. And you can see here, create treatment plan for present data, that has an 8. We have done a little bit on that today, so I'm actually going to add 2. And when I move sections, I probably should have propped back over here to my Trello and started timers here. I'm still working on that, got to get better at that to get tracking done so that appropriate charging for later stuff can happen. But yeah, that is kind of what an hour in the life of a data scientist looks like. We got so much done. Anyway, if you have any questions, feel free to pop them in the chat, and I will see y'all next week. Have a good one. Bye.